Okay, so for this precipitate lab here, we're going to be mixing 6 solutions. They are all at a concentration of 0.1 molar. Here are the identities of the 6 solutions. I have a few spot plates here lined up so that when we put in solutions 1 through 6, going down these rows here, 1 through 6 in this fashion, it'll do all the mixing and matching for us here. Remember, a precipitate is a solid that crashes out of solution here. All we need to observe here is which ones do form a precipitate. For the ones that do form a precipitate, we're going to try to take our formula equation, write a complete ionic equation, and then our net ionic equation. So I'm just going to take solution number 1 here. I have just them on the side here. I have little dropper bottles here. I'm just going to drop in a few different drops here, just of solution number 1. They should be clear to begin with, okay, because they're not mixed with anything so far. We are going to sort of duplicate some of our combinations, so I don't necessarily need to go down this row as well. So you're going to see on the lab handout here, basically we can stop at this dividing line here. So that there is solution number 1. I'm going to continue here with solution number 2. So for solution number 2 here, we're going to again go across the row. Okay, so this is our aluminum sulfate solution here. And again, just to do the combination, let's say 2 to 1, what I'm going to do here is I'm also going to add solution 2 to this row here. And again, what we're doing here is we're looking for the existence of any precipitate that forms. We're going to continue on with solution number 3. This one here is sodium acetate. Sometimes when we do this lab here, we actually start changing the solutions just to introduce sort of different ions that potentially form. Okay. So just sort of for the solutions I have listed for you here, we can match it up with the solubility table later on and see whether the precipitates actually formed in the combinations that we're doing here. In any case that there's some discrepancy here, you're going to see if you can make some combination discussion why that is. So solution number 4 here. Again, I'm just going to, just for completeness sake here, I'm going to go across the entire row, but technically speaking here, we're actually doubling up some of these mix and match combinations here. We just want to at least have one look at which ones form precipitate. So solution number 4. Moving on to solution number 5 here. So we have our potassium iodide solution. Again, I'm just going to go across the row here. So 1, 2. And just one last solution here, solution number 6. So okay. So again, just trying to make some qualitative observations here. Which one looks like they ended up forming precipitates? Only for the ones that do. See if you can write a net ionic equation for the actual double placement. Thanks, guys.